At the end of the last video, I left you with these three problems, and I just wanted to work through them together. So when I'm evaluating an inverse trig function, I find it helpful, same way when I'm evaluating logs, actually, to give it a name, but in particular to give it a name that reminds me that it's an angle. And then I'm able to take this equation and rewrite it using the more familiar trig function. So this tells me that cosine of theta is negative root 3 over 2, and with inverse trig, it's always two things. This is the cosine, and theta has to be in the interval from 0 to pi. Okay. So I'm going to look at the sign. This one's negative. 0 to pi corresponds to quadrants 1 and 2, and if cosine is negative, we're in quadrant 2, just like we were last time. So my picture looks something like this. Here's my theta. It's going to be an obtuse angle. Alpha is my reference angle. Okay. Now, I know that cosine of alpha and cosine of theta are related. They have the same absolute value because I use the reference angle to find that absolute value. So I can say cosine of alpha is the absolute value of negative root 3 over 2, which means it's root 3 over 2. But alpha is an acute angle. Oh my goodness, I'm inspired once again to draw my 30, 60, 90 triangle. 1, 2, root 3. The angle whose cosine, the acute angle whose cosine is root 3 over 2, is 30 degrees, which would be pi over 6. So our alpha is pi over 6, and then I can see theta's just that much shy of being half of a revolution. So theta was pi minus alpha, so that's, I'm going to write it as 6 pi over 6 minus pi over 6. That's going to be 5 pi over 6. Okay, so I'm going to actually just write that in. That's 5 pi over 6, and we can box that answer. Gotta love it. Okay, next question was arccosine of 0. I'm going to start out exactly the same. I'm going to give it a name, and a name that makes me think angle. That gives me an equation that I can now rewrite with the function I'm more familiar with. I'm better at working with cosine than working with arccosine. I'm just more familiar with the trig functions. And I teach this stuff, and that's still the case. Okay? So I always rewrite it the way I'm more comfortable. Cosine of theta equals 0, and if it's inverse trig, there's always the additional information about what was the restricted domain of the function we inverted, which has now become the range of the inverse trig function. So theta has to be in the interval from 0 to pi. Now, ordinarily that has me thinking quadrants 1 or 2, but I recognize that 0 is one of my special values. That corresponds to a quadrantal angle. Now, if I'm looking at the interval from 0 to pi, I'm really actually just looking at the top half of the unit circle. 0 is a quadrantal angle. That would intersect the unit circle at this point 1, 0, but cosine there would be 0 because cosine is the capital X value. At pi over 2, we intersect the unit circle at this point 0, 1. The capital X value is 0. Okay. So I can see that's the angle that I'm going to want, pi over 2. Notice at pi, we would intersect the unit circle at negative 1, 0. Okay. So it's going to be pi over 2. Excellent. Okay. So if I can see that I have a quadrantal angle, I want to just go to the unit circle, figure out which point my terminal ray has to intersect the unit circle at, and there should be a unique angle in the interval that passes, whose terminal ray passes through that point. All right, the last question, we were asked to graph arccosine of x and then state its domain and range. So here, I want to start with y equals cosine of x, where x is in the interval from 0 to pi. That's the function that we're going to invert when we create arccosine. So that's going to look like so. where this point here is the point 0, 1, and this point here is the point pi, negative 1. Okay. If I look at y equals arccosine of x, we're switching the roles of x and y, and remember we can do that by turning and flipping. Let's see. I don't have it drawn out this time, but if this was my page on which I had drawn this, I'm going to rotate 90 degrees to the right, and then I'm going to flip it top to bottom. Then my graph is on the back side, but if I hold it up to the light, I should be able to read through it. What I'm going to get when I do that is, notice this point will become negative 1 pi. This point will become 1, 0. And this point in the middle, we crossed the x-axis here at pi over 2. That means we're going to cross the y-axis at pi over 2. So we'll have a point, we'll have a point 0, comma, pi over 2. That's going to become the y-intercept of things. And so the graph that we get should look something like this. And again, anytime you have a graph that starts somewhere and doesn't just go off so that you don't have an arrow at the end, you want to make sure that you indicate that there is a point there. Okay. All right, so there's our graph of arccosine. What's our domain and what's our range? Well, the domain would be the x values that we can plug in. That's the interval from negative 1 to 1. Now I can get that by looking at this graph and just reading it from left to right. That's where I've got graph. But I also know that the domain of the inverse function was the range of the original function. And the range of this is negative 1 to 1. It matches the range of the full cosine function because we chose this so that we got all of the y values. So we have the same range, we just only got them once. Okay. And the range, that's my y values, that's my 0 to pi. And again, the range of the inverse function matches the domain, which was our restricted domain here for the cosine function. Okay, excellent. We'll move on to arctan in the next video.